We've introduced the idea of limits informally. Now we've established the definition for what a limit is, given some more formal structure to how we can express limits and answer different limit questions. So let's apply those ideas to some additional examples. So we want to use this graph below to find each of the limits, starting with the limit as x approaches -2. So as we're considering this graphical approach, we again want to start by considering both the left and right hand limits, determine if those are equal to each other or somehow different. So we can start with the limit as x approaches 2 from the left hand side. So in this case, at x equals -2, as we approach from the left hand side, we're approaching this function value of -1, 2, 3. So as we approach from the left-hand side, our function is approaching a value of 3. As we approach -2 from the right-hand side, we're approaching that same function value of -3. And again, since our left-hand limit, right-hand limit are both equal to each other, we can say that the limit as x approaches -2 of our function is -3. And again, keep in mind that limit exists even though we have an open circle on the graph here. The function is actually defined at this disjoint point. So even though we never hit that function value of -3, we're getting closer and closer to that value from both directions. So similarly, let's take a look at what's happening as x approaches -1. So as x approaches -1 from the left-hand side, we're approaching a function value of -4. So we also want to consider the limit as x approaches -1 from the right-hand side of our function. In this case, as we approach from the right-hand side, we're in this different section of the graph, and we're approaching a function value of 1, 2, 3, +4. So in this case, the limits are not equal. They're opposites of each other. So we have to say that the limit as x approaches -1 of our function does not exist. So our function doesn't have a limit at -1, even though it does have a left-hand limit, right-hand limit. Since in this case those are different, the limit itself doesn't exist. And in our last example, or our last example for this question, we want to consider the limit as x approaches 0. And again, we'll do that from both the left and right-hand sides. So as we approach 0 from the left, we're approaching a function value of 2. As we approach 0 from the right, we're approaching that same function value of 2. Since those two one-sided limits are equal, we can say that the limit as x approaches 0 of f of x is going to be equal to 2. In what are sort of a couple of follow-up questions to example 1, in example 2, we're asked, is it possible to define f of -2 so that the limit as x approaches -2 of f of x is equal to f of -2? So what we already know from example 1 is that this limit is equal to -3. So what we're being asked is, can we change something about the function we were given so that f of -2 is equal to -3? So in this case we could. At x equals -2, our function is defined by this point. But if we changed our function, so if we erased that point and instead moved it down here, we would fill in that hole in the graph And now the limit would be exactly the same thing as that function value. So yes, we can do this. If f of negative 2 were equal to 3, so we're changing this about the original function, then the limit as x approaches negative 2 of our function, which is negative 3, would be exactly the same thing as f of negative 2, which would be equal to 3. So if we were to change something about our graph as it was initially given to us, then we could make those two values equal to each other. In example 3, we're asked similarly, is it possible to find f of negative 1 so that the limit as x approaches negative 1 is equal to f of negative 1? So at x equals negative 1, our function value is defined as negative 4. We already know from the first example that the limit as x approaches negative 1 doesn't exist. So in this case, whether we leave our function value here, or if we erased that, changed the definition of our function and made that filled in circle up here, it wouldn't change the fact that that limit doesn't exist. So in this case, no. Since the limit as x approaches negative 1 of f of x does not exist, we can't make this happen. So essentially what we're saying is, no matter what we defined f of negative 1 to be, keeping it where it originally was or moving it to this new value, the limit still doesn't exist because we're approaching different values from the left-hand side and right-hand side.